So this is my third video on special theory of relativity, and in this video I will be talking about postulates of special theory of relativity. So the first postulate is the principle of relativity, and the second postulate is the principle of constancy of the speed of light. So what is this principle of relativity? So in the previous video on Galilean transformation, we have seen that the acceleration in both inertial frames are same. So therefore Newton's laws are invariant under Galilean transformation. So this is a very important principle in mechanics. So basically this is a well-known fact in the classical mechanics. So the laws of physics are same in all inertial frames. So take an example. Standing on a railway platform, you can drop a stone such that if it hits your left foot. So if you repeat the same experiment inside a train that is moving smoothly, this is important, with uniform velocity, the stone will again strike your left foot. So if you perform one experiment at rest and another experiment in an inertial frame that is moving with constant velocity, so you cannot distinguish between these two experiments. So we can't distinguish between two inertial frames by repeating the same experiment. So no experiment done inside the train can tell you that the train is at rest or moving. So that is basically the principle of relativity. So here is the key idea. So there is no preferred inertial frame. So there is no special inertial frame. So you can choose any of frame and call it at rest and other in motion. So here in an example, so let's say this is our S frame and this is our S prime frame, and this is moving with respect to U. This is moving with respect to S with a constant velocity U. So this is our one situation. Although if I say that this S prime is at rest and this S is moving in this direction with speed U or minus U. So both of these situations are equivalent. These two situations are identical because the motion is relative. So if you are standing on a bus stop, and so you can say that the bus is in motion, but an observer on the bus will see that the observer on the on the bus stop is in motion. So both of these two situations are identical. So here is the point. Identical experiments give identical results irrespective of the frame involved. So no matter which frame you choose, so if you are doing the two same experiment, so you will get the same results. So this is the principle of relativity. So the second postulate is that the principle of constancy of the speed of light. And the statement is that the speed of light in free space has the same value c. So this c is a constant for all inertial frames. So this is the statement, and let us discuss this. In the previous video we talked about the Galilean transformation. So we found that the velocity transformation equation. So if this is one frame that is moving with respect to c, let's say this is x prime frame and this is s frame which is at rest. So if you know the velocity of a particular event or particular system in this s frame, so you can shift into this s prime frame using this particular equation. So look here. So if Vx is equal to c, if let's say there is a light is emitted here and speed is c at this point, so in this frame we measure that the speed is c. So according to Galilean transformations, the speed of this particular flash of light in this frame will be Vx prime c minus v, according to this velocity transformation equation. But the experiments tell us, or the second postulate tells us, that in that frame the speed will be c. So in both of the frame the light has the same speed, so it is an experimental result. So it is somehow against the common sense. So let us discuss more. So the speed of light c is obtained from the Maxwell's equations, and these equations are basically the governing equations of the electromagnetic theory. So this relation is given this, so c is equal to 1 over mu naught epsilon naught square root, and this gives me this value. So the speed is obtained from the Maxwell equations. So now there are two possibilities. So first possibility is that the Maxwell equations are not general. So they have different forms in different frames. Means in S frame we can get a speed relation for light like this, and in another frame this relation will be different because the Maxwell equations are not general. And the second possibility is the Galilean transformations are not general. They are not correct for this situation, because we have obtained this situation that Vx is equal to V is equal to Vx prime. So we obtained this equation, but according to experiment we get Vx and Vx prime equal. So it is also possible that this equation, the velocity transformation equations, is not correct, and therefore the Galilean transformation are not general, or they are not correct. So here, if Maxwell equations are not general, then in each frame they have a form. Similarly, so we can find speed of light in one frame and repeat experiment in other frame. So of course if they are not general, so we will get different value of speed. So this is one frame, in another frame we will get this value. So we can get speed of the frame, because in one frame if I get this value, see another frame I get this value, so I can see that what is the difference. So that difference will give us the speed of the frame, which is the violation of principle of relativity. So principle of relativity says that the identical experiments should give you identical result. So this is not possible. It means that Maxwell equations do not have the different forms in each frame. So Einstein trusted Maxwell theory that and principle of relativity. So Einstein trusted the Maxwell theory that the speed of light is given by this relation in all frames, that the Maxwell equations are same in all inertial frames, and he also trusted the principle of relativity, so that the identical experiments should give you identical results. And so the Galilean, this is the only possibility that the Galilean transformations are not general. You should remember that the principle of relativity is derived from the Galilean transformation. We have done this in the previous video, but Einstein rejected this idea that the Galilean transformation are general, but he trusted the principle of relativity. So therefore in the development of special theory of relativity, there are some other transformation which are known as Lorentz transformation, and these transformation equations are more general. So that was all for this video. So in next video I will derive the Lorentz transformation.